Hello, and welcome to Richardson RFPD Tech Chat. My name is Chuck Cook, Senior Application Engineer at Richardson RFPD, and with me today is Mr. Martin Mills. Marty is the Director of North American Sales for LiCAP Technologies. We're here today to discuss supercapacitors in power backup situations. In particular, we're going to examine power backup for wind turbine pitch systems. So let's get started. Welcome, Marty.
Thanks, Chuck. I appreciate you having me. I look forward to our chat.
So let's start by learning, what does a pitch system do?
Well, pitch control systems are adjust the blades by rotating them into a neutral position so they don't spin out of control should the turbine lose power to the grid. They also can optimize the wind energy to get maximum power, and they also are a very important safety system. In case of a catastrophic event, they can rotate the blades out of the wind.
So what types of pitch systems are there?
Well, there's two primary types. There's electric pitch systems, and there's also hydraulic pitch systems. So maybe we can talk a little bit about both. Right now in 2019, 2020, about 40% of the pitch systems are hydraulic that are primarily Vestas, Siemens, and Gamesa. And the other 60% are electric pitch systems from GE, which uses lead acid batteries, and Goldwyn and Envision that use ultracapacitors or supercapacitors.
So what's the difference in electric pitch systems that use batteries versus supercapacitors?
Well, that's a good question, Chuck. Supercapacitors versus batteries, you get much longer life out of a supercap than you can with a battery. You can get roughly 10 to 15 years versus anywhere between 2 and 4 years with lead acid batteries. They're more reliable. They're very predictable to predict life. They've got a wider operating temperature range from minus 40 degrees C to plus 65. And they can operate up to 1 million charge-discharge cycles with ultracapacitors versus batteries that are in the thousands of cycles. Ultracapacitors are much safer. They can be fully discharged. There's no lead or acid in ultracapacitor. They're electrostatic energy storage devices. And they're lower operating cost, but you do have an initial higher cost, but the ROIs are typically anywhere between 2 and 3 years.
So Marty, are there any wind turbine manufacturers that are using LiCAP supercapacitors designed into their pitch systems now?
Yes, there is actually. We have 2 OEMs that we work with, Re-Energy, that's using our UltraCap modules on an OEM level, and Mingyang Wind Power as well.
Are there any other types of systems that have been developed?
That's a good question, Chuck. I'm glad you asked. We've developed an ultracapacitor retrofit system primarily for GE electric pitch systems and 30 newton meter and 20 newton meter pitch control systems. We've also partnered, since we have the expertise for the ultracapacitor side, we partnered with Windurance, who has developed a centralized charging unit, and we're also partnering with Richardson as our channel partner.
So what does this system consist of?
Well, we have two really different systems, but the primary one, probably the biggest market that's available to us out there, is the 30 newton meter ultracapacitor energy storage system. It utilizes 6 cells in series that are rated at 2.7 volts per cell, but we actually operate them at 2.4 volts to extend the life of the ultracaps. They're 500 farad modules. They operate at 14.5 volts. There are 6 ultracapacitor modules in a 30 newton meter system, a single centralized charger that's all enclosed. All these components actually are all IP20 rated. And the wiring harness and mounting brackets and associated hardware are included in what we call a kit or an assembly per blade. We also have a 20 newton meter system that uses 4 ultracapacitors versus the 6 in the 20 newton meter system. But the CCU is essentially the same, and just the bracketry and hardware would made up to the appropriate battery box configurations.
Marty, that's really interesting. But I think we're kind of out of time for today. Sounds like we should take a deeper dive and look into the retrofit system design and follow up and talk about why they're higher reliability. Thanks again for sharing all this information and taking the time to chat today, Marty.
Thank you, Chuck. I appreciate your time. We'll look forward to our next chat.
Great.